Hello everyone, welcome back to Unit 3 of the Advanced Java course. We're still diving deep into object-oriented programming, so this is the last chapter of the unit, which is interfaces. So what is an interface? As you've already learned, objects define their interaction with the outside world through the methods they use. So methods form the object's interface with the world. So for example, the buttons on your television set are an interface between you and the wiring on the other side of the plastic of the remote. So you press the power button to turn the television on and off. Infrared and everything will take its place. So in its most common form, an interface is a group of related methods with empty bodies. So in the Java programming language, an interface is a reference type, similar to a class, that can contain only constants, method signatures, default methods, static methods, and nested types. Method bodies only exist for default methods and static methods. So interfaces cannot be instantiated, kind of like abstract classes. They can only be implemented by the child classes or extended by other interfaces. So interfaces share some common characteristics with abstract classes, and their application can be sometimes very confusing. So just remember that an interface is a collection of related methods whose headers are provided without implementation. So basically interfaces are skeletons or an outline that contain no actual code but have detailed guidelines. All the methods are both public and abstract by default, so you don't have to explicitly declare it. So here I have an interface and I have not put any headers on the side of it. So interfaces can provide a framework for the behavior of pretty much any class. So when a class implements an interface, you can think of the class as signing a contract, agreeing to perform the specific behaviors of the interface. If a class does not perform all the behaviors of the interface, such by not implementing any of them, it has to be declared abstract. So a class that uses the implements keyword to implement an interface. The implements keyword appears in the class declaration following the extends portion. So if you were doing extends and implementing, you would have to do the extends part and then you would do the implementing part. So when implementing interfaces, there are several rules to keep in mind. A class can implement more than one interface at a time. A class can only extend one class but implement many interfaces. An interface can extend another interface similarly to the way a class can extend another class. So for example, if I went here and I said, okay, I can implement flying object, but if animal, say, was an interface, I can also implement that as well. So you can have multiple. So a class that can implement an interface can define any number of methods. So in particular, it contracts to provide implementations for all the methods declared in the interface. This is really important. Any class that implements an interface must implement every method specified. So every child class that implements the flying object will have to provide implementations for fly and is flying. So if it fails to implement all of these, it must be declared abstract. The class that implements it must be declared abstract. So the classes that implement an interface may represent objects that are vastly different. So they all, however, have a common capability or feature expressed in the methods of the interface. Now let's take a look at example code here. We have an interface called flying object that has abstract methods fly and is flying. All classes that implement this interface must provide implementation for these methods. So we see that the classes bird and airplane implement the interface using the implements keyword. So note that the airplane class both inherits from the transportation class over here and implements the flying object interface. So remember that the extends keyword must precede transportation and then it will then implements will follow straight after. So one last thing before we look at an example is the difference between abstract classes and interfaces, and to identify which scenarios each of them should be applied, because it is, like I said, very confusing. Remember that an abstract class is still a class, and you can provide implementation for some of the common methods. So for example, if I declared transportation to be abstract, these two can be implemented and I can have an abstract method with it. For an interface, all the methods are public and abstract. So just keep that in mind. So you should use an abstract class for an object that is application specific and it's incomplete without the subclasses. but an interface is a contract or a guideline to where all of the methods are abstract by default. So in the previous chapter, the class animal was abstract because it is specific to the animals, and it doesn't make sense without any of the subclasses such as dog or cow. So you should use an interface when its methods can be applied to a variety of programs. So we made flying an object an interface, but there are many different objects that fly, like birds and airplanes. So other than that, the fact that they fly, they have no other common characteristics, which is why we don't use an abstract class. It doesn't make sense. An interface cannot provide implementation for any of its methods, whereas an abstract class can. An interface cannot contain instance variables where an abstract class can. And an interface and an abstract class can both declare constants, but it's not possible to create an instance of an interface object or an abstract class. So they have those traits in common. So well, that's the end of this unit. So hopefully you now have an understanding of what inheritance, abstract classes, and interfaces mean.